On the surface, it feels like magic. You type a few words into a blank box, and out pours a paragraph, a poem, or a piece of code that seems to understand your intent with an almost unnerving intuition. It's a machine that writes, reasons, and even creates. But what if I told you that this digital wizardry, this great leap forward in artificial intelligence, is built on a foundation of a single, simple, and very, very old idea? The secret isn't in a flash of divine intelligence, but in a relentless statistical prediction. It's not about knowing the meaning of every word, but about understanding the relationship between them. This is the story of how large language models, these incredibly powerful systems, are built, and it all begins by learning to see the world not as words, but as numbers. So, how do we get from a sentence like, "The cat sat on the mat," to the numbers we're talking about? The first step is something called tokenization. A large language model doesn't see words, it sees tokens. These tokens can be a word, a punctuation mark, or even just part of a word. Think of it as a vocabulary list of roughly 50,000 unique pieces. Every sentence you give it is first chopped up into these tokens. This brings us to the most beautiful and fundamental idea in the whole system: word embeddings. For an LLM, every single token in its vocabulary is represented by a list of numbers, a vector. And it's not just any list of numbers. The genius is in how these numbers are arranged. Imagine a vast, invisible map. 100 or 1,000 or even a few thousand dimensions. On this map, words with similar meanings are placed close to each other. The vector for king is right next to queen, but the vector for table is somewhere else entirely. This is the model's intuitive sense of meaning, encoded in pure mathematics. This isn't just about proximity. The relationships are also meaningful. The difference between the king vector and the queen vector is the same as the difference between the man vector and the woman vector. The model has implicitly learned that man and woman are the gender axis of its language map. These simple lists of numbers carry with them a stunning amount of information about our world and our language.